Here's the series FRQ from 2019. I thought this was a great one. It's got a lot of good stuff in here. I don't think this one was as difficult as what I've seen some years, so I wouldn't say this is the high end of what you might see, but there's some good stuff here. So anyway, they give you a function here. They show the tangent line. They give us a bunch of nth derivative values, and you'll notice here they're then going to ask us to write the third degree Taylor polynomial about x equals 0. They're actually asking us here to find a Maclaurin polynomial. And keep in mind, third degree means you just go out to the x to the third term. Okay, they have not been using the term Maclaurin the last couple of years. So Taylor series, of course, is the general term, and Maclaurin is specifically when it's centered about x equals 0. Anyway, I highly encourage you to write down the formula before you start doing anything, because then you're just substituting things in. So the pattern is very simple. It's the nth derivative divided by n factorial times x to the n. So 0th derivative, which is really just the functional value at 0, divided by 0 factorial x to the 0. First derivative at 0 over 1 factorial x to the first. Second derivative at 0 over 2 factorial x squared, and so on. And then you can just kind of drop everything in here. Now, we need f of 0. If you go back and look here, f of 0 in the original function is just 3. Okay, so that's going to be 3 over 0 factorial. And then x to the 0 is just 1, so we just get 3 as our first term. Okay, we need to have prime at 0. And originally I didn't know what was going on here, but if you notice, they gave us a tangent line, and you can find the slope here. If you use this point up here and that point down there, the slope is going to end up being -2. So the derivative at 0, because that whole line is going to have the same slope, including where it passes through 0. So the slope of that line is -2, okay, over 1 factorial times x. So I guess it's going to be -2x, okay? The second derivative at 0, if you go back, that's in the table. The second derivative at 0 is 3, all right? So it's going to be 3 over 2 factorial, so that's 3 halves x squared. And again, they want a third degree function here, so we need to go to the x to the third term. And the third derivative there is the oh-so-catchy -23 over 2. And let's see, we're going to have a 3 factorial in the bottom here, so it looks like it's going to be -23. So -23 over 2 divided by 6 should be -23 over 12 x to the third. And that's what we look like we have here. Before we go on, we're going to check this just to make sure. Obviously can't do this on the AP exam, but we can do it now. And we've got 3 minus 2x plus 3 halves x squared minus 23 twelfths x cubed. Looks good. All right. Next part here says write the first 3 non-zero terms of the Maclaurin series. They did use the term Maclaurin series for e to the x. We want the second degree Taylor polynomial for e to the x times f of x about x equals 0. Okay. So hopefully you know the e to the x series, 1 plus x squared over 2 factorial plus x cubed over 3 factorial, and so on and so forth. They only want up to the x squared term. They want us to multiply that by the first, up to the second power term of the function we just worked with. So I've gone ahead and written that down here. And anyway, we can multiply this out. Keep in mind here, they want the first 3 non-zero terms. That's going to be the 0 degree, first degree, and second degree. Anything that's going to give you a third degree or higher, you don't even need to multiply out. So this is really just kind of FOIL. 1 is being multiplied by each of these values here. So that's going to give me 1 times 3 is 3, 1 times -2x is -2x, 1 times 3 halves x squared is 3 halves x squared. Then we're going to take x times 3, which is 3x. I'll line it up with my other x's. X times -2x is -2x squared. And we don't need an x cubed term, so I think we're just done with that part. Now we'll multiply this by 3. We'll get a 3 halves x squared. And I think that's it. So let's try to simplify all this. It looks like we're going to get 3 plus x. 3 halves plus 3 halves is just going to be 3. Minus 2 is 1. Is it plus x squared? Let's check this out. Let's see if the answer is correct. That would be great if it is, because then we can move on to another part. Oh, it is. So we're already up to 4 points on this, which is solid. I was hoping for 5, but hey, you know, that's how it works sometimes. Okay, so nothing terrible yet, I don't think. Moving on to part C. Let's see. And by the way, the last one's an error bound. We're not going to do the error bound in 2020. Probably regret that in future years if I use this video, but oh well. Okay, part C says, let h be the function defined by the integral of f of t. Use the Taylor polynomial found in part A to find an approximation for h of 1. Okay, not f of 1, h of 1. So we got to do this integral function here, and that's going to be the integral of 3 minus 2x plus 3 halves x squared. Looks like we are going to be using that 23/12 x cubed as well. And we're taking the integral between 0 and x. By the way, I just realized here, I really shouldn't have made these t's because x is going to be one of our bounds. So that should be a t, that should be a t. We should take the integral with respect to t, just some other variable other than x since they're using x for something else. So anyway, nice thing about series, it's really easy to take integrals. So 3t minus t squared plus 3/4, no, just kidding, 1/2 t cubed. Looks like minus 23/48, that's catchy. T to the 4th. We're evaluating this between 0 and x. Okay, so that's going to give us 3x minus x squared plus 1/2 x cubed minus 23/48 x to the 4th. Okay, if you sub 0 in here, all of these are going to go away. So you're actually just going to be left with, I'd probably rewrite it if I was doing this on the actual exam, but it's actually just going to end up being that. And I think they wanted us to use that to do an approximation. We want an approximation for h of 1. Okay, so that's going to be our h of x there. So h of 1 would be equal to 3 times 1 minus 1 squared plus 1/2 times 1 cubed minus the oh so catchy minus 23/48 1 to the 4th. And so that's going to be 3 minus 1 plus 1/2 minus 23/48. I believe if you just left that, they would take that. Anyway, let's go ahead and take a look at their answer here. What do we have here on this part? This is part C. Did we get the integral right? Looks like it, that we substituted in here 3 minus 1 plus 1/2 minus 23/48. Looks like if you simplified it down, 97/48. But again, I'm pretty sure they would take that as an unsimplified answer instead of the 97/48. So don't waste a lot of extra time unless you have it. So anyway, not going to look at the error for this year since it's not on the 2020 exam. Not a terrible FRQ. I wouldn't mind seeing that on tomorrow's exam.